This is about the sum of an arithmetic sequence. So we have our arithmetic sequence here. We have that constant difference of 3. And so what a sum means is you're going to take and add up all of the numbers that are given in that sequence. And so we're going to be doing partial sums here. That's what this is. And so we denote that sum for the first n terms in the arithmetic sequence by s sub n. So we get these two formulas. So let's try it first, and then I will show you where it comes from. So in order to use the formula, you need a sub 1, d, or a sub 1 and n. And so you want to use what they give you. So it says find the sum of the first 7 terms, and see a sub 1 and a sub 7 are given. So that works really well for the last one. So if we want s sub 7, I would then replace all the n's with 7. This means that we can just plug it in. Our a sub 1 is negative 3. Our a sub 7 is negative, between the math in my head, negative 4. And so this would be 7 over 2 times negative 7, which is negative 49 over 2, or negative 24.5. Now, why do we have two formulas? And that's for the next one. So now you can see on this one, it wants the sum of the first 100. So we're going to go s sub 100. Well, we're not given the 100th term. So if you use this one, you have to find it, which is fine. You can do that. But if we just use the first one, we plug that in. We can now use our a sub 1 and our d. And where do we find that? From our formula. So from our sequence, a sub 1 is 1. And then difference, remember we just subtract any of the two. And there we go. So I can plug in my a sub 1 and my difference. And then just plug that into my calculator and it will tell me what I have for an answer. And it gives us this. So if I plug that in my calculator, I get 10,000. You can also just take your general term, right? Our a sub equals a sub 1 plus n minus 1 times 2. And so as a sum, this would be I equals 1 to 100, first 100 terms of our general term. So that is a way to figure it out as well. We know that that's every single term. So if we plug that into our calculator, you get the same answer. See, they both come out to be 10,000. Either one, however you look at it, it's 10,000. So on this last one, what we need to do is actually find our a sub 1. It's giving us nothing. So we need to find an a sub 1 no matter what, and a difference here to find our formula for our sum. So if you remember, we can then treat each of these points as an n comma a sub n and make a general term like a linear equation. So this is 9 comma negative 12. This is 13 comma 3. And so our difference would be our slope, which is negative 12 minus 3 and 9 minus 13. So this is negative 15 over negative 4, which is 15 over 4. And when we finish, we'll verify that a sub 9 equals negative 12 and a sub 13 is equal to 3. Now, we take either one, it doesn't matter. I'm going to use a sub 13 equals 3 to make my general formula. So I know my a sub 13, which is 3, would be my first term plus 12 differences. And my difference is 15 over 4. So a little quick simplifying. So this would be cancel, 3. 3 times 15 is 45. So subtract 45, subtract 45. And we get a sub 1 equals negative 42. So we now know our a sub 1 is equal to 3, and not 3, negative 42. Our difference is 15 over 4. And so we can use this to find a sub 10 or just plug it in our formula. And we're going to use the latter. So s sub 10 would be 10 over 2. 2 times our a sub 1 plus, and then we'll put it in there, 10 minus 1 times our difference. So again, you look at your formula, and it's 10, 10, and then a sub 1, and then 10 minus 1, d. And so our a sub 1 is negative 42. You can plug it in. And our difference is 15 over 4. So just to verify those 2 points are correct, let's look at our Desmos. So I have my difference is 15 over 4. My a sub 1 is negative 42. So we're starting here. And you can see 9 became negative 12. And 13 is 3. Remember, we're just finding the slope. So going from 9 to 13, what's our rise and our run? That's our difference that is carried through everything. So each point is, say, a horrible 15 over 4. So after we find our a sub 1 and d, and we plug them into our formula, we could just use a calculator now to find out what our answer will be. And there you have it. And I also use a general term. We have a starting value of negative 42. There's our x minus 1, and then our difference. So I just plugged in the general term, and look, they're the same. So there you have it. Should have wrote that down. Negative 251.25. Now what if it says it wants it in fraction form? Then you do answer fraction, and we get negative 105 over 4. 1005 over 4. And there you have it. So those are the 3 different types you're going to run into for finding sums, where they give you a starting and ending point, or an actual sequence, or 2 random points, and that's how you do it. So I'd show you where the formulas were. That's what I told you at the beginning, where it came from. So if we take a sub n, we get this expanded out. And so I'm going to expand each one. A sub 2 would be 1d. A sub 3 is a sub 1 plus 2d's, and so on and so. So a sub n is our general term. Okay. So now if I take all the a sub 1's and put them together, I would have n of them. That's n a sub 1's. And then I pick all the d's and put them together. And then I factor out a d because they all have a d, and I end up with 1 plus 2 plus 3 plus 4 all the way to n minus 1. So if you remember, that's our summation formula, and we're going from 1 to n minus 1, right? So that would then be plugged in. If you remember, our summation formula is n plus 1 over 2, and we'll put I plus 1 so we have a different letter. But if I plug that n minus 1 in, I get this. Plugging in the n minus 1 there, I get here. So we end up with this, which becomes this. And then they both have an n, so we factor that out, and I end up with this. And you go, okay, well, let's get rid of the half too. So I factor out a half. That means I have to put a 2 in front of my a sub 1, so that half of 2 is 1. And there it is. There's our formula. And then to continue on, if we take that a sub 1 and break it up, so we get 2 a sub 1's is a sub 1 and a sub 1. We can then say a sub 1 plus dn minus 1 is a sub n. And there it is. There are our formulas, and that's where they come from. Thank you.